Do I have to pay for it? No, I'm an artist. It doesn't cost me anything to come up with those prompts. And no, it doesn't. It's free for me. I don't know. It's probably free for you guys. You've got like a Microsoft account through the university. So I don't know if it costs for people who don't have a mic. I really don't know. It's got like fast generating ones. And then when you run out of those, it takes longer, but I'm told that there's an open source one that will let me generate all the Donald Trumps that I desire, but I haven't gotten around to installing it on my computer yet. All in good time. Because as much fun as those are, to combine them with current living political figures is much more fun. All right, well, I'll begin with a word of prayer. Dear Father, we thank you for today. I thank you again for the students. Just ask you to bless this class, help us to glorify you in what we do. And I just pray for the students that they would use the rest of their time this semester wisely, that they would just be able to study for all their finals and just complete this semester well, Lord. In your name I pray, Lord Jesus. Amen. So let me just talk about, well, any questions? You guys have any questions about anything? Let me get I don't know why I put that away. I'm a dummy. Come on. No, don't turn off. Turn back on. Oh, it's turning. System's turning off. No. How about don't do that? Well. All right. Well, you can do it. It's thinking about it. All right, you know what? It's thought long enough. Let's see here. See how you do without power. One of these is a plug. Ah. Oh, well. Oh, okay. I'll let you live. I'll let you live. So many of you have emailed me already when you want to take the final. You know, if like you wanted to take it some other time, like when's our official time in here? Oh, 8 a.m. Tuesday, December 12th. What a stinker of a time. So yeah, if you want to take the final in one of my other time slots earlier, by all means. If somehow magically all of you do that, and then I didn't actually have a Tuesday 8 a.m. final, that would be wonderful. But I don't think that's going to happen. There will be somebody who needs to take it that time. Otherwise, it wouldn't be scheduled then. But anyway, a lot of you have emailed me already. If you do want to take it before Tuesday, it's important that you let me know when you want to take it so that I have enough finals on hand for wherever I go. So these are basically the 4 time slots that you got to take a final with me. You know, starting this Friday, 3:30 to 5:30, and then the Monday after that, December 11th, I have one at 8 in the morning. I have another one at 1 in the afternoon to 3, and then I have the you know, Tuesday 8 to 10. If you need extra time and you like to take it in the testing center, and of course you have like ODAS accommodations, then by all means, I don't mind, just email me so I know to do that for you, okay? Because otherwise I'll assume you take it with a class in person. If you don't want to do that, if you want to have it, you know, in the testing center, then let me know and I'll make sure there's one over there for you, all right? But you should email me to tell me you're doing that, all right? I don't know. Obviously, you don't have to tell me right now. There may not be anybody in here like that. I can't remember. People drop the course and add the course. Well, they don't add, but they drop. Some people do drop. Any questions? Okay. Any questions about the final? All right, well, nobody wants to know like how many questions there are in the final? Or? There we go. Like it's like a law. You guys will ask about how many questions are on the final. And that's just because I made you ask it just now. But somebody here wanted to ask it. They just didn't want to ask it because anyway. There are, I think, something like 40 independent question stubs, but technically there's 22 questions, but some of those have like A, B, C, D, E, you know. But like all together there's like 40 probably about 40 to 45 separate like little answer these different questions. So it is only 8 pages. So it's about 40% the length of a mission. But let's see here. I can give you a quick rundown of the test. Let me do that. I think that might be helpful to you, right? And then I'll just stop and do some examples as we go through as is helpful to you guys. So like problem number 1 is just factor polynomials over the reals. It's got like A, B, C, D, E, F. It's got all the different cases you might encounter for factoring. It's all there. If the polynomial is prime, then write prime as your answer, all right? Problem 2, it's got 3 parts. There's 3 different inequalities. Solve the inequalities. Give the answer in interval notation. I'll just tell you the general problem types there. I have one that's a polynomial inequality. I have one that involves absolute value. And I have one that involves a rational expression, rational inequality. So I think it's probably healthy for us to review those right quick before I go on, because it's been a minute since we've done any of these. So let's just run through a couple of these. I'll start out with something kind of annoying. What if we're up against something like, oh, I don't know, x squared minus 16x plus 1, let's say, less than 0. How would you solve that? So you should take a look at that in about 3 seconds and go, I can't factor that. So what does that mean? If you've got a quadratic and you can't factor it nicely, you have to complete the square. That's right. So this is x minus 8 quantity squared minus 64 plus 1 less than 0, which is to say x minus 8 quantity squared minus 63 less than 0. So that factors into x minus 8 plus the square root of 63 times x minus 8 minus the square root of 63 less than 0. So I can make a sign chart based on this. My 2 critical numbers are 8 minus the square root of 63 and 8 plus the square root of 63. If you think about this for a second, you should kind of anticipate what the sign chart should look like, right? Because if we think about this guy right here, if we just think about y is equal to x squared minus 16x plus 1, graphically, what is it? It's a parabola that opens up. My bad. That's not what it looks like. Goodness gracious, let me think about this for a second. I think it looks more like this. There, it's something like this anyway. Like both of these are positive, because the square root of 64 is 8, and that's a little bit smaller than the square root of 64, so it's about 7.9 or something, the square root. So they're both positive. These are both positive, the critical numbers. But my larger point is the pattern should not be surprising. The pattern for the sign chart here should definitely be pluses on the outside and minuses in the inside, right? So what's the solution? The solution is some vandal needs to come in and screw this board to the wall. See here, some very constructive vandal. 8 plus the square root of 63. So there you go. That would be the solution here. So for a polynomial inequality, what's the technique? What do? We find the places where it's 0 and write a sign chart to solve it, right? So problem 2, let me do some really silly examples here to start with. How about if I have 3x minus 2 plus 3 less than 1. And example 3, I'll do absolute value of 3x minus 2 plus 3 greater than 1. So you guys should be able to solve these without really any work, because they're kind of silly. Truth be told. How did they go? This one, the example 2, is what? You've got absolute value of 3x minus 2 less than minus 2. Is that possible? Can we have an absolute value which is negative? No. So the solution here is no solution, right? There is no real value which solves that. On the other hand, example 3, if we look at this, we have 3x minus 2 is greater than, well, minus 2. Is that true? It is true, right? Absolute value is greater than or equal to 0. It's non-negative. It doesn't even matter what x is. So the last section, I posed an example like this. They told me there was no solution to this one. And I said, oh, no, no, no. Opposite story altogether here. In this one, the solution is everything. Because there is no restriction whatsoever placed on x. So the solution set in this case is just all real numbers. Because I can certainly take the absolute value of 3x minus 2 for any real x. It's just a real number, right? All right, so let's look at ones that are actually interesting. So how about this? What if we're up against the absolute value of 13x plus 8 greater than 1? How do you solve something like that? What technique do we use? Remember, we have a theorem. There's like 2 different cases. The greater than case or the less than case. For the greater than case, we have two separate scenarios we have to deal with. They're separate. They're disparate. They're 2 different paths to go down, if you will. So we can either have 13x plus 8 less than minus 1, or we can have 13x plus 8 greater than 1. And we're not talking about the same x in both cases. These are separate cases. And so like this, well, okay, I subtract 8, I got 13x is less than minus 9. Over here, I've got 13x is greater than minus 7, which either gives me x is less than minus 9 over 13, or I have x is greater than minus 7 over 13. So my solution for this one is minus infinity to minus 9 over 13 unioned with minus 7 over 13 to infinity. So that's the solution to this guy. All right, so let's look at a different one. What if we're, example 5 here. What if we have the absolute value of 13 minus 7x less than 2? How would you solve that? I'll throw an equality in this time just to illustrate how that goes. What's the difference? Well, it's very different, right? Because now we're talking about less than or equal to, not greater than or equal to. And so the rule for solving this is just totally different. We don't have to break into separate cases. We just do one compound inequality. We can take care of it. See, what we have is minus 2 is less than or equal to 13 minus 7x is less than or equal to 2. That's an equivalent compound inequality for the given absolute value inequality. We can solve that thing through our usual bag of tricks, like subtract 13. Subtract 13, what happens? We get minus 15 less than or equal to minus 7x less than or equal to, what's 2 minus 13? Negative 11, right? Now you gotta be careful. Since we've got a negative coefficient in front of x, when we divide by minus 7, we reverse the inequalities. So what was previously less than becomes greater than. All right, so divide by minus 7, and we get, 15 is greater than or equal to x is greater than or equal to 11. I'm sorry, that was 15 over 7, 11 over 7. And I don't like writing it this way. I'm going to flip it around. That's 11 over 7 less than or equal to x less than or equal to 15 over 7. That's equivalent. Right? So my solution is 11 over 7, 15 over 7, and my solution currently is incorrect. Why is it incorrect? What did I do? What's wrong with my solution? We're dealing with less than or equal to, right? Can we include the edge cases? We can, right? Less than or equal to, so it's not parentheses, it is bracket. Yeah, we need brackets here. There you go. Answer. Any questions? Do you guys remember how to solve the rational inequalities? Like if you have like a rational function, how to do those? Should we look at one of those? Yes, no? Then I'll speak at once. Okay, I see some nodding. All right, so example 6. Suppose you've got something like x plus 8 divided by x squared minus 2. Let's say that's less than or equal to 0. Let's see if we can solve that. All right, so can we factor? Can we factor this? Well, yeah, I think so. I mean, we've got x plus 8 divided by x plus the square root of 2. X minus, that's definitely something you should, that should be in your repertoire, so to speak. Something you should be able to do without a lot of thinking is if we have a difference of squares, you should be able to use the a squared minus b squared is a plus b times a minus b formula, right? Like that difference of squares factoring. The fact that you need to put square root of 2 there shouldn't stop you. We need to know this. It's an important factoring example for this course. It's always on my final, I think, like without exception. I will have a factoring like this on the final somewhere. Okay, anyway, what are my critical numbers? Well, critical numbers for this one, minus 8, I think that one comes first. And then you've got like minus root 2, and you got plus root 2. Those are your 3 critical numbers here. And I just need to test some points. So if you look at my expression, if I put some big number into it, I think we've got plus, 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 right? And then each one of the factors has a multiplicity of 1, which means we flip signs at each critical number. So it's going to give us like pluses, minuses, pluses again, and minuses over here. We're trying to solve less than or equal to, so my solution is equal to, let's say, minus infinity to minus 8. And do I include or exclude that minus 8? Include? Very good. Why is that? Because that gives us a 0 in the numerator, which is fine because we're solving less than or equal to 0, right? Then we do union with minus the square root of 2 to the square root of 2. Now, am I right? Do I need to include, do I do parentheses or should I put brackets there? Do I need to include or exclude plus or minus root 2? No, I definitely want to exclude, because the reason I want to exclude is because that would give me division by 0. Because these are from the denominator, which if I put equality here, I would be in trouble. I'd have division by 0, so we can't have that. So that's the difference. And there you go, that's the answer. Okay, so I think that's, roughly speaking, the kind of stuff that's on page 2 of your final, all right? Come on, computer, come back to me. All right, let's see here. Problem 3 is like a case-wise defined function kind of problem. Problem 4 is about solving polynomial equations. Let's look at a couple of those together. How do we solve polynomial equations? What are the different things we've done to solve polynomial equations? You guys remember? Let me start out with like a super easy one. I guess the question is, are we solving over the real numbers? Are we solving over the complex numbers? Like what are the instructions? And I think I have one where I say solve over the complex numbers, and I think I have another where I say find the real solutions. I'm not 100% sure about that, but Yeah, I guess technically speaking, in problem 5, I just say find the solution set. So if I say find the solution set, let us understand that I mean the real solution set, okay? If I say real or complex, then I'm allowing the possibility of complex, all right? So let me just say this. If I'm allowing the possibility of complex, I explicitly mention it, all right? So example 7, because there are a lot of equations we look at in this course that, truth be told, in the complex analysis course, we find many more solutions we don't talk about here. It's true. Here's an easy one. I don't know, like 8 minus 3x quantity squared equals to minus 11. All right? I say this is an easy one because anytime you have a square equal to something, we can solve it by using the square root property. So the square root property says, aha, this is just giving me 8 minus 3x is equal to plus or minus the square root of minus 11. But we prefer to write that in terms of the imaginary notation, square root of I times root 11. And so I get minus 3x is equal to minus 8 plus or minus I root 11. And then dividing by minus 3, I get, well, minus 8 plus or minus I root 11 divided by minus 3. And you could simplify that, but that's good enough for us here. So there could be a problem like this, okay? Now, there also could be a problem that's more like the following. Could you guys solve, let me see if I can come up with something a little bit tricky. X cubed minus 3x squared plus 3x minus 1 equal to 0. Can you guys solve that one? Admittedly, this is a little bit trickier. This isn't, I wouldn't say this is the easy, this is not, I wouldn't classify this as an easy problem. But if there was something like this, it should be possible that you could get it, because we did talk about the binomial theorem. We did talk a little bit about how this is, well, this is x minus 1 cubed, right? That Pascal's triangle business, looking for the binomial coefficients, how that expands out like that. So in view of that, the answer is x equals to 1 is the solution, all right? Just x equals to 1 is it. Okay, so okay, admittedly, this is a little bit of a, that's kind of a nasty problem, admittedly. Let me show you something a little bit less, not so nasty. How about this? What if we had, oh, I don't know, x to the 5th minus, oh, I don't know, 81x equals to 0. All right, this is, okay, I said this wasn't nasty. I guess to be fair, I think this is of moderate nastiness. It's not, I don't think of this as mean as example 8. We should all get at least one of the solutions to this problem. Because your first thing you should do should be to what? Whenever you don't have a constant term, what do? Factor out what? X, right? So factor out x here gives me x to the 4th minus 81, right? But then we can do more, right? Because x to the 4th minus 81, we can factor further. That's actually what? X times x squared plus 9 times x squared minus 9, right? And we can then factor x squared minus 9 further, can't we? So, I mean, we've got x times x squared plus 9 times x plus 3 times x minus 3. So the first problem on your test, I ask you to factor polynomials. So in the first problem on the test, factoring polynomials, you're not looking for numbers, right? You're just looking for how to factor the polynomial. So like if you look at this example and you just ignore the 0 here, right? This is just a factoring problem so far, isn't it? I've just showed you how to factor x to the 5th minus x, 81x completely over the reals. See, this x squared plus 9 is prime. We can't factor that further without using complex numbers. So this is how x to the 5th minus 81x factors. But now I'm faced with a different question than problem 1, right? This question on the final, if there was something like this, I'm looking for the solutions, right? The real solutions to this problem. Okay, let's say no, let's say context, we're not looking for complex solutions anymore, just real solutions. If we're just looking for real solutions, this gives us nothing. But the real solutions are what? We have x equals to 0, or minus 3, or 3. All right? Does this make sense? Yes, no? All right, let's see here. So, problem 5, I've got like a function, solve an equation involving a radical. Maybe I should just remind you guys a couple of those, because that's more test 2 stuff. I'm trying to focus more on test 1 and test 2 today, because test 3 is still kind of fresh, right? And you can look at the video I posted Friday. I go through the solution to test 3 there pretty quickly. You shouldn't have trouble. It's what's that? Do you have like practice final tests? I don't think so. No. I would advise looking over the old the tests and the quizzes we had in here. That should be a good path. Yeah, I believe so. Let's see here. So at least solutions are posted. All right, so a problem involving a radical, something like, what example am I on? 10? Thank you. I don't know, so if I just make one up, it's going to be too ugly, so I'm not going to finish it, but I'll start it, okay? So something like x plus 3 is equal to, this 2 minus the square root of x minus 1, something like this. How would you solve something like this? What do you do? Or here's an easier one to get us started on this. What if I have the cube root of 2x plus 10 equals to 7? Oh, I regret putting a 7 there. I'm going to trade that 7 out for a minus 2 there. So something like that, that's easy. The natural enemy to the cube root is the cube. You just cube both sides, and you get 2x plus 10 is equal to minus 2 cubed. Well, minus 2 cubed is minus 8. And so this gives me 2x is equal to minus 18, which gives me x is equal to minus 9. So that problem I can solve pretty efficiently. The other one is much trickier, but what's the first thing you want to do? Problem like that, example 10. Square both sides? No, we don't want to do that, because if we did that, it just makes it worse. It's like first you need to isolate the radical. That's what we got to do first. First isolate the radical. So I'll move it to the other side. I got square root of x minus 1 is equal to minus 1 minus x, I guess. Right? Or, I don't know. Maybe it's better to put the minus over here and make this x plus 1. I mean, whatever. However you want to look at it, okay? Does that make sense? So once I do that, square both sides. And so I get x minus 1 here. And on that side, FOIL it out, we get x squared plus 2x plus 1. Aha! Well, now we've got x squared minus x squared plus x plus 2, I think. All right. And maybe this has no solution, actually. This is what? This is x plus 1/2 squared minus 1/4 plus 2. In other words, you've got x minus x plus 1/2 squared equals to minus 7/4. 8 minus 1 is 7. Put it the other side, you get negative. This has no real solution. So this problem has no solutions. But we've worked out problems like this in class, and we've gotten different cases, right? Sometimes we get 2 solutions. Sometimes we get, and they both count. Sometimes we get 2 solutions, but one of them is extraneous. We got no solutions, right? Those things are all possible. I could get that. Thank you. All right, let me continue on here. The second part of problem 5 is like an exponential equation, kind of like test 3. I should take a moment to talk about something, because this confounded like half of the class. Half the class got this wrong, which is not good. And I don't think it's a mistake you'll make again, because it's not. There's just a blind spot in your algebra. All right, let's talk about it. So it was this problem, 2 to the x equals 3 to the x. A lot of you just got stumped on this. And you were going down the right path, but you just kind of got stuck. So we take the natural log of both sides, right? And when we do that, we get x log 2 is equal to x log 3. And at that point, you guys were kind of like, I don't know what to do, you know? But what you should do is to bring everything to one side and factor x out. So we got log 2 minus log 3 equals to 0, which gives me x equals to 0. Why is that? Because this number here, the natural log of 2 minus the natural log of 3, well, that's just a non-zero number. It's just a number. And if you've got x times a non-zero number equal to 0, that forces x to be 0. And in retrospect, I think we should all see, oh, of course x equals to 0. Look at the original problem, right? 2 to the 0 is 1. 3 to the 0 is 1. You might have been able to guess that without doing this algebra even, right? There's a great danger actually in me asking this question, because once we've had this conversation, if I ask it again, none of you are going to do this algebra. You're just going to look at it and you go, x equal to 0. We talked about this. I don't need to go through all this writing, all this mathematical mumbo jumbo. Forget that. X equal to 0, answer. And I couldn't really count you wrong, because you could guess x equal to 0 as the answer here, right? It's not outside the realm of plausibility. All right, let me go on, because I want to finish the final purview for you. So I'm just going to talk and not write so much. Problem 6, it's like a match game. There's like 4 graphs, match them up. Problem 7, find the coordinates of the vertex of a parabola. Problem 8, I have like a rational function, question about graphing a rational function. Problem 9, I give you the graph of a polynomial and ask you to construct the formula for it. Problem 10, 11, 12, and 13, these are all either exponential or logarithmic equations like you guys saw on test 3, all right? So problems 10, 11, 12, and 13, all test 3 style exponential log equation kind of stuff. Problem 14 is a simplify rational or simplify polynomial expressions kind of problem. I think that might have been a test 2 kind of question. I can't remember. It might have been test 1. I just don't remember. I'm sorry, guys. Problem 15, it's a rational, solve a rational equation. So, we solved the rational inequality in example 6. If I put an equals 0 there, that would be a rational equation. But the one on the test is more interesting than that. Like you probably have to make a common denominator or something, Problem 16 is long division. It's a question about long division. Problem 17, it's one of those ABC kind of problems, like you're supposed to simplify the expression, find ABC. It's one of those. Problem 18 is possibly a new question, but it involves concepts you've already seen, so hopefully you get it. You can get it. It's within the realm of possibility, but this might not be a problem you've seen before. You should use what we've talked about this semester to solve it. Problem 18 might be a genuinely new problem. Problem 19 is 3 equations, 3 unknowns. You all should knock that out of the park. Problem 20 is a find the inverse formula. Problem 22 is a find the inverse formula. Problem 21 is another test 3 style exponential type equation thing. So that's your final. That's it. All right. So I wish you well. I hope you guys read the announcement I just made about grades. It's what I'm basically saying there is like, don't sweat if there's like a column where it says doesn't count towards the final. That's not particularly meaningful. I take the numbers in Canvas and I run them through like an Excel sheet, and I make my own like total points for the course column after the final. And that's where I do all the stuff like dropping the test grade and putting the final exam grade in place of it. Yep.
If I failed all 3 tests, is it still possible to pass the class if I pass the exam?
Yes, as a general point of order, if you've done all your homework and like I think everybody has pretty much a perfect quiz grade in here, give or take a person or two, but pretty much everybody hasn't lost point on quiz. You guys, I'm grateful if you do the course survey, but I have literally no way of telling that you haven't, so everybody gets those 30 points. So long story short, the points that you've lost will be points that you didn't get on the mission. That's the main contributing factor. If you've actually done all the missions, more or less, then pretty much if you make a C or higher on the final, you've made a C in the course. If you make a B or higher in the final, probably made a B in the course. If you make an A on the final, you probably make an A in the course, is what it boils down to. Yeah. Mm-hmm.
Can we bring a formula sheet for this?
Oh, great question. You are allowed 3 formula sheets for the final. 3. Yeah, like 1 for each test. You can basically bring back the 3 you had if you want, front and back. Mm-hmm. They can be printed. They can be handwritten. I don't care. It's all good. You're even allowed a magnifying glass if you do so choose.